Hi. In this video, we're going to continue looking at Boolean operators, but in a little bit more detail. In particular, we're going to consider Boolean operators in the context of truth values. So let's just bring back our regular truth table. We have these inputs for x and y, and then we have the result of x and y, and x or y. So normally, Boolean operators are defined to operate on Boolean values and return Boolean values. In fact, it's called a Boolean algebra, and or are just operators in that Boolean algebra. And that means that these operators are only defined for Booleans and will always return a Boolean. So for example, if we have true or false, that will return true. We could even use comparisons like this. So in this case, when a equals 2, b equals 3, then a is greater than 0, it's true, and b is less than 5, that is true, and then true and true will return true. So we deal with Boolean inputs and we have Boolean outputs. But now consider that every object in Python has a truth value. We have this concept of truthiness. And so for any object, we really could write the following. We can write bool x and bool y. That is perfectly legal. Since x has a truth value, we can get the truth value by calling bool on x, and we can get the truth value of y by using bool of y. And we can do the same thing with or as well. So the thing is that we actually don't have to write bool here. In fact, we can just write x and y. Or we could write x or y. That will work perfectly well. Python will use the truthiness of x and the truthiness of y to get our result and to evaluate x and x or y. So the question then becomes is what's actually returned when we write this expression here where x and y are not Booleans but just objects that have an associated truth value. What is being returned? Is that a Boolean? And the answer is no, it's not. It's not a Boolean. So let's see what's going on and let's see how Python actually defines its and or operators. So let's start with or. And I'll just bring back the truth table for or right here. So x or y is defined this way. If x is truthy, it will return x, otherwise it returns y. And Bob here is a little puzzled, right? What's going on? This isn't kind of the standard thing we think of when we think of the or operator. It's not a traditional way of teaching it. So does it work as expected with just Boolean values? If we just use x and y as Booleans, does this at least seem to correspond? So let's take a look. Let's just run through the different options. So let's take x and y, both false. So the rule is x is false, so we are going to return y, because the rule is that if x is truthy, we return x, otherwise we return y. So x is false, so we return y. Well, y is 0 in this case, so we get false. Right? And I'm using 0 and 1 as true and false. So if x is false and y is true, then x is false, so we still return y. So in this case, we return 1. And so far, we're matching, right? 0, 0, return 0, 0, 1. We have a 1. So far, so good. What about 1, 0, where x is true and y is false? Well, x is true, so we need to return x. And so we return 1. And this still matches our regular truth table. Finally, if we take both of them equal to true, well, x is true, so we still return x, which means we return true. Okay, now one thing to note here is that if you look at what's happening, if x is truthy, we return x. Otherwise, we return y. Did you notice that we never actually look at the value of y? We never do, right? And if you look at the truth table, that kind of makes sense. Because if x is true, well, we're always going to return true. It doesn't matter what y is. Now, if x is false, then we just return y. We don't have to do another operation to find the or. If x is false, we know that the result is going to then be totally dependent on y. So a better way to define this in terms of what's actually happening is that if x is truthy, we return x, otherwise we evaluate y and return it. And the reason why I want to write it this way is because now you'll notice that we don't actually evaluate y unless we need to return it. And you remember this whole short-circuiting thing we talked about in the last video? That's what's going on. That's why y is not getting evaluated unless it has to, right? So if the first part of the first operand is true, then we just return true, but we never evaluate the second part. If the first operand is false, then we have to evaluate and return y, because y doesn't have to be a pure number or a pure Boolean. It could just be an expression, could be a function call, or something that is, that returns either a Boolean or an object that has an associated truth value. So that's the reason why we have this definition here, and it actually works. It's kind of pretty cool, actually. And in fact, the or and the and operators return an object. They return one of your operands, either x or y, depending on, whether x is truthy or not. So let's look at and. And is defined very much in the same way. But if you think of the and, well, if the x is false, we always return false. If x is true, then we have to return y. You'll notice that these two, the 0, 1, 0, 1 match here, and the 0, 0, 0, 0 match here. So if you think about it a little bit, you can probably come up with a definition yourself, which is if x is false, return x, otherwise return y. All right? So let's take a look. So x and y, if x is falsy, return x, otherwise return y. So again, does this work as expected with Boolean values? So let's take a look. Let's just run through it very quickly. If we have false, well, x is false, right? So we return x, so our result is false. That matches. Next one, if x is false and y is true, well, it still doesn't matter. We should still return x, right, according to this rule, and we return 0, which matches what we have in the truth table. If x is true and y is false, well, x is true, so now we have to return y. So in this case, we'll return 0, which again matches our truth table. And similarly, if both are true, then because x is true, we have to return y, and therefore we return true, which is exactly what we have in the truth table. So this checks out as well. Now, for the same reason that we discussed with the or, y doesn't actually get evaluated unless it gets returned. So again, we have this short circuiting, because if x is false, then we are just going to get false back, and this y will never get evaluated. So our definition really is, if x is falsy, return x, otherwise evaluate y and return it. And again, we have the short circuiting, and this will then return the objects, the operands that we pass in. The operands could be Booleans, in which case we get the usual normal results, or we could pass in any objects. So let's look at the consequence of this with the or operator first, or at least a consequence of it. So again, just bring back our definition. If x is truthy, we return x, otherwise we evaluate and return y. So again, this does both the definition and also handles the short circuiting. So let's take a look at this example here. Let's say that x is none and y is this string NA. Then x or y, well, x is falsy, so we're going to return y, which means we return NA. Similarly, if x is an empty string and y is NA, well, the empty string is also falsy, so we're going to return NA. On the other hand, if we take x equal to hello and y equal to NA, well, in this case, hello is a truthy string, right? It's a truthy object. So we are going to return x, which means we return hello. So you'll notice that in both these cases here, where we had a string that was either none or empty, we returned NA. And when I say a string, we had a variable that was none or an empty string. We returned NA. And in the case where our variable was a string with characters, we returned the string itself. So if we write something like this, a equals s or NA, then if s is none, we return NA. If s is an empty string, we return NA. If s is a string with characters, we just return s, right? And we assign that to a. So this is basically a way to set up default values for a variable, right? So we may be dealing with a string, and we don't want to have an empty or none variable there. So we can do s equals s or NA, and this will ensure that a is always going to be a string, right? It's always going to be, well, it's always going to have something in it, right? This is making the assumption that s is a string, or is pointing to a string. But anyways, you get the idea. So we can use this for setting up default values. So let's take a look at an example, because we can expand this further. We can say a equals s1 or s2 or s3 or na, and this will then be, so a will be equal to the first truthy value, and it's the first truthy value because, as we mentioned before, in a case like this we have these multiple OR operators. Python will then evaluate them from left to right because these are all operators with equal precedence. So it will do a left to right evaluation. So essentially it's going to grab the first truthy value, and since the last one is always truthy, you're ensured that a is going to be at least na, or it's going to be the first non-empty string in S1, S2, or S3. So you can expand that a little further. So that's really handy when you're working with variables, and especially if you're pulling data from places that you don't really know, like maybe a database that could have nullable string fields or nullable text fields, or maybe it's from an API feed from somewhere. Whatever it is, it can be really handy to do things like this. Let's take a look at another example. Let's say we have an integer variable that cannot be 0. For some reason or other, we have this integer and we don't want it to be 0. And if it is 0, we want to set it to 1. Now, obviously, you could write an if statement. If a is, equals 0, then a equals 1. You could do something like that. Or, since 0 is a falsy value, we can just write a equals a or 1. It's going to be the same thing. It's going to return 1 if a is 0, or it's going to return a if a is non-zero. So again, pretty handy to do. Let's look at some consequences of AND now, and what we can do with it. So again, just recall that x and y, if x is falsy, we return x, otherwise we evaluate and return y. So let's look at this example. Let's say x is an integer with a value of 10, and y is 20 divided by x. Then x and y will return y, right? Since x is truthy, we will return y. We will then evaluate y, which is 20 divided by 10, which is 2, and that's what gets returned from the x and y. On the other hand, let's say that x was 0, and y is also 20 over x. Then it's going to return 0 because x is falsy. It's going to return that. It will not even try to evaluate 20 divided by x. So it looks like we were able to avoid this division by 0 error by using the AND operator. And this is a pretty standard way as well. We can say x equals a and total divided by a. Let's say we're trying to calculate an average where we have maybe a sum like total and a count, the number of samples, which is a. And at any point in time, we could have a count that a be 0. We don't know, right? Maybe it's right at the beginning. We haven't entered data yet. We're trying to compute the average. Well, this will then return a. It will not try to do the division by 0. But if a is greater than 0, then it will do the actual computation. So again, very handy to have. So as an example, if we have a equals 10, well, 10 and total divided by 10, that's going to return total divided by 10, right? But if a is equal to 0, then we have 0 and total divided by 0, that's going to return 0. Okay. So that avoids basically that division by 0 error. Again, that's a pretty standard trick that can be used in Python. Let's take that example with the average that I was talking about. So let's say we have sum and n. So sometimes n is non-zero, sometimes it is. In either case, the average is n and sum divided by n. Because if n is 0, we have no count, right? Then the average is 0, so we want to return 0. On the other hand, if we do have values, so n is non-zero, it's going to be some positive integer, then we do want to take sum divided by n. That will be the average. Here's another example. Let's say you want to return the first character of a string s, or an empty string if the string is none or empty. So in other words, we have a string and we want to bring back the first character of that string. But of course, if the string is none or empty, we just want to bring back the empty string. So let's see how we could do that. Here's one option. If s, return s0. Otherwise, return the empty string. Well, yeah, that will work, right? If s is none, or if s is a string with length 0, it's going to be falsy, right? So it's going to return this empty string here. But if x is a string with characters, then its length is greater than 0, which means that it's going to be truthy, and we're going to return s0. Option number 2, which works equally well, and actually works works equally well. We can say return s and s0. Now, it's not option 2. Return s and s0. Well, that's kind of okay, right? Because if s is none, or the empty string, then it's going to return s, because it's going to be falsy. Otherwise, it will return the first character. So this will not create an error. We won't have an exception. This will work just fine in all the cases where s is none, s is an empty string, or s is a string with characters. However, what is it going to return when s is none? Right? It doesn't work well with the none case. It's not going to do what we want it. We want it to return an empty string if the string is none. Here, it's going to return none if s is none. So how can we fix that? Well, we can take whatever this returns and we can OR it with the empty string, so that if the return of this thing here is falsy, which means none or the empty string, we're going to replace it with the empty string. So we can do it this way: return s and s0 or the empty string. And that will do exactly what we want. In fact, you can make this default value now whatever you want. So you can have, it will return the first character of the string, or maybe it returns NA if you want, if it's an empty or none variable. And of course, Bob thinks that's really cool. You know, I do too. But that's kind of a cool way of doing this. It's, you know, it's a one-liner, and once you get used to it, it's very easy to recognize this pattern and to understand it, and you don't have, you know, as wordy code as you have over here. So lastly, let's look at the Boolean not operator. Now the not is really a built-in operator that returns a Boolean value. So it doesn't work quite the same way as and or, where and or were returning objects, right? It doesn't do that. It actually returns a, you know, honest Boolean value. So if you do not x, then the way it works is that if x is falsy, then it will return true, right? Because x is false, so we return not false, which is true. And it will return false, the Boolean false, if x is truthy. So it can still take any object here, but the not will actually return the not of the truth value of the object. So if we take an empty string, for example, which is falsy, then not an empty string, it's an empty list, it's still an empty sequence, then not this empty sequence will return true. On the other hand, if the sequence contains objects, it is truthy, and therefore not of that will actually evaluate to false. Similarly, if none is falsy, then not none will be true. So let's go ahead and actually switch to some code, and we'll take a look at all of that in action in the next video. So thanks for watching, and I'll see you in a bit.